right, folks, I'm here to talk about 3D foam foundations. And here's the thing, we got to take these foundations first. 3D foam designs require a holistic approach, meaning simply that you have to be mindful and prepare for foam from design through digitizing and into execution. If you don't design for its strengths, digitize for its needs, or use the right materials and methods, your foam designs may literally fall flat. With that in mind, let's cover some basic considerations critical to creating 3D foam designs. First thing, for designing for foam, you got to face it, it's not for fine detail. That you can successfully use foam on relatively fine lines. The smaller the sensitive strokes are, final details you try and capture in foam, flatter your design is going to be. The biggest, boldest designs will consist of wide, unbroken satin stitch columns, hence why those classic varsity letter designs or other large letter designs are still king in the foam world. That said, we can combine and shift that layer of satin columns into complex designs or use fills over foam, as long as you remember that the edge of the foam is going to need some special treatment. When for designing a foam, you just got to think about being bold. Next thing we have to deal with are digitizing basics. Not every design works for foam, and the primary considerations for foam digitizing consist of some structures and settings that create the cutting edge that perforates the foam. We have to digitize so that it can easily tear away while the top stitching maintains adequate coverage. It means we have to cap open column ends on satin stitches and use around twice the density that we would use for regular coverage. For flat embroidery, it's going to be twice that. So when using filled areas over foam, fill stitches, we won't need that immense density, but we'll have to consider that it has to have a border on it or some sort of undercutting at the edges with a high density column or structure. No matter what we see in the design, these edge elements need 1.5 to 2 points or 0.15 to 0.2 millimeter density in the stitching to cut cleanly. I like to start at about 1.8 points or 0.18 millimeters in density on any of my cutting edges. Next, we have to think about having materials made for the purpose. Not all foam produces the same results. High-density embroidery-specific foams make it possible to achieve that look with that high crown. They remain thicker after stitching and can have a slightly sharper edge to your columns, while softer foams compress more, result in designs that look more rounded or have a lower crown on satin stitch strokes. 3D foam comes in multiple colors and thicknesses. Some embroiderers are going to even stack foam to achieve thicker decorations. Testing a known good design that you know runs well with multiple thicknesses and types can let you build a material palette from which to select the best foam for your intended outcome. The ideal is to use just enough thickness to arrive at the dimension desired while matching the foam's color or tone as much to the top stitching as you can. Extremely tall foams can lean or shift during running, and for that, you might want to look at the ability to raise the presser foot as well if you're doing things that are incredibly thick. If you don't have that, though, do know that all the foam I've created in my career I've done on machines that didn't have presser foot adjustment. You still can create successful foam designs with that. But for most single-layer foam treatments, I go to that 3 to 4 millimeter thickness available in dense foams, and for multi-layer work, sometimes we'll build up with thinner foams and try and build no higher than 6 millimeters. Next, we have to go to our execution on the machine. You have to have that execution correct for excellence. Foam requires special treatment to run its best. Operators can secure foam in a number of ways, either by taping a slightly oversized sheet of foam to the area, spraying a light coat of embroidery-specific adhesive on the reverse of the foam, or using bands or elastic straps to hold it into place, especially for caps. Whatever you do, you just want to keep that foam secure. Some initial stitching in your design can also help tack the foam into place. Additional adjustments to the machine may help, but many achieve fine results without too much alteration. You can elect to reduce thread tensions if your initial set shows show too much compression. And while some swear by certain needle types, I use the proper needle for the underlying garment rather than switching needles for foam. My results just haven't differed as much because of needlepoint geometry, but the underlying fabric or garment structure is still going to interact with the needle as they always do and sensibly stitch better when the right needle is used. So for those who have the ability to adjust presser foot height, lifting the foot to level the foam surface can avoid some compression. But as I said earlier, I've done the largest part of my work on machines that don't do that, and we still get a pretty good crown, even if it's not the kind of extremely high crowns and stability that you get from machines where you can adjust that presser foot height. So even with less sophisticated setups, you can achieve really great looking foam. Lastly, let's finish strong. Foam always requires additional finishing after embroidery to look truly clean. Smooth foam designs will require additional tools and time. Though it feels like you should be able to stitch, rip away the excess, and pick or tweeze out some stuck bits and be done with it, there's more to get the cleanest results. For the smoothest designs, you need to bring the heat. carefully apply low indirect heat to reduce the kind of fibers that are there after removal. It will not remove large chunks of foam that might be in the corner, but will reduce fuzziness, and the design will look tighter. Take care with light fabrics and threads, and with the type of thread used, polyester can melt, light colors can scorch if you apply the heat too much too long. The best tool to achieve this, in my experience, has been an adjustable heat gun, so you can adjust that heat down a bit and dial it just the amount that you need. To have people use lighters, have people use hotter heat guns, yes. Have I made the toasted marshmallow white hat? I have. So you can scorch, you can damage things. Go light, keep moving, and use indirect heat. But the thing is, manual intervention is a must, and all it means is occasionally you're going to have to poke in a small errant bit of foam under the stitches while you're tearing away the excess. Though you want something with a fine point, it needs to be a blunt instrument that won't damage thread. If you find a chunk sticking out consistently in one area of your design, however, consider using specialty stitches or talking to your digitizer and checking stitch angles to make sure there's not something that you could do to perforate that better or to hold back the foam with a special underlayment. Though often, just rubbing the design with a clean piece of stabilizer at the end after you use your heat or lightly scraping the back of your thumbnail over a column can help spread out thread if you just have a little bit of bunching where you're having some minor show through. The thing is, 3D foam doesn't have to frighten you if you start with those firm foundations and you end with that clean, careful finishing. And that's my secret sauce for today.